Alright, today's lesson is going to be about amino acids. And amino acids are very important when it comes to understanding the biology of life, or biochemistry of life, because amino acids are the core components, the core building blocks, if you will, of proteins. And to be able to understand amino acids, you first have to understand its structure. And so that's what we're going to talk about today, is the molecular structure of amino acid. Now, at the very center of every amino acid is a carbon molecule. This is known as the alpha carbon. Carbon, not carbon. And it creates 4 different covalent bonds with 4 different molecules. And we know from organic chemistry that when a carbon makes 4 covalent bonds, it's in the sp3 hybridization. Okay, and so the one of the bonds that it makes, or 3 of the bonds actually that it makes, are the same across all amino acids, and those bonds are a simple hydrogen, covalent bond with a simple hydrogen, another covalent bond with a carboxyl group, so a carbon that has a double bond with one O and another bond with another hydroxy group, and it also makes a bond with an ammonia group, or an amino group, because it's connected to a carbon. So we call this the amino group, NH2. Like I said, we call this one the carboxyl group. And now, because we're able to make many different proteins, where amino acids come in very handy is that they have this other group that varies. And now there are 20 different variations of this amino acid. And so instead of writing them all out right now, we're just going to use R as basically a variable to account for all these. And this group is called the side chain group. And we'll, in other videos, talk about the different side chains that are put in this position. And then how those side chains can interact with each other to form a protein, the structure of a protein. And that's important because with the structure of a protein, it determines the function of the protein. Now, this isn't exactly what amino acids look like in the body, because in the body we have a pH of 7. And when the pH equals 7, like it does in the body, here's what this actually looks like. So this carbon right here, or this carboxyl group, loses this hydrogen, and so we're going to delete that there, and it remains like this. And so since it loses a hydrogen, it loses a positive charge. This negative charge is revealed, so it has this. However, on the other side over here, this amino group gains a hydrogen, because we know that ammonia is a weak base. So this actually gains a positive charge. So the entire electro sign of the molecule, it's neutral. It's electroneutral. However, it's something that we call a dipolar anion, because it has both this negative and this positive. And so we call this a dipolar anion. A dipolar anion, because it has 2 poles, a positive pole and a negative pole. So we did a little bit of organic chemistry tie-in just a minute ago when I told you that this carbon right here is in the sp3 hybridization form. This carbon right here, because there is a double bond, and because it forms covalent bonds with 2 other molecules, so 3 atoms, total, we know that this is in the sp2 hybridization. Now, there's one other thing from organic chemistry that we can tie in based upon this carbon molecule. As you can see, with the exception of one amino acid where this is a hydrogen, all of these groups are going to be different. Okay, and we know that when a carbon and sp3 hybridization forms 4 different bonds, then optical isomers can be formed when you look at it in the 3-dimensional structure. And so that exists for amino acids too. So amino acids can exist in both the L and the D isomeric form. However, when it comes to which amino acids our body uses, our bodies only use the L isomer. And so here's what that looks like. So imagine here's your alpha carbon. And in this situation, we're going to take this hydrogen and we are going to put it into the screen. Okay, so into your computer screen behind this carbon. Okay? Then you have the remaining 3 groups here. For the L isomer, we'll put your side chain group up top, and then your amino group here on the left, and your carboxyl group here on the right. Now for the D isomers, these would just be flip-flopped. But since this one is the one that's important to life, we will call this the L form optical isomer. In future videos, we will go and start talking about these different side chain groups that are here. Now there's only 20 of them, but to really understand biochemistry and thus the structure of proteins, which then leads to the function of proteins, which is important in understanding all of life, this is one of the things that we have to memorize, but we'll do it in a way that makes sense in a logical way. So anyway, that is the structure of amino acids.